Hello, we are going to do a video on 8M4 lesson 1. We're going to see if we can make sense of how we write and set up word problems. This is typically can be a challenging chapter for many students, 7th, 8th grade, even into high school. So let's see if we can just kind of, take our time, solve some of these problems and see if we can learn something here. Let's move over to our Sketchpad and look at some problems. These are out of these problems here are wait a minute, what's going on here? I don't want this. I want settings. Wait, something's going on with my Sketchpad here. I want to be writing. Here we go. There we go. So these are out of 8M4. Wow, dyslexic today. 8M4 lesson 1 and Great Minds, Eureka Math. And we're just going to work each example 1 through 9. We'll see how far we get as we explain word problems. Okay, so let's go. So let's look at this first one. And in each question, we're always looking at, we're going to be writing solutions using variables. Right? So we're going to be using variables, and all variables are unknown numbers. They're unknown numbers, kind of like, and then they're placeholders. They're placeholders for the unknown numbers. So, for example, if I say I have, well, let's just look at number 1 here. So we talk about Bruce has 2 books, and one book costs him more, $4 more than 3 times the other, and together the books cost him $72. So we don't know. The question here on number 1 is, do we, or really, what don't we know that we need to know? Right? And the question is do we need to know the size of the book, the height of the book? And no, what it is that we need to know is we need to know the cost of the book. And do we need to know the cost of one book or the cost of the other books? So let's see, let's look at this. We have 2 books, and we have one book, and then we have the other book. So we are going to have to say that something equals we'll just call this like the first book. Sorry for those who hear that noise. That's a printer going right now. So we don't know. So we have a first book price and a second book price, and we don't know either one. So the key, let me just put down key number 1, is let's have a variable for the smaller of the 2 things. And that's just going to make it easier. You could have the variable be the larger, but let's see. Which one is the smaller one? One book costs $4 more than 3 times the other. So which one's bigger here? One book, the first book here, costs $4 more than 3 times the other. So this first book is the one that's really expensive, because we're going to take this second one and we're going to multiply it by 3 and add 4, and then we're going to get the cost of the first book. So we're going to use a variable for the second book, this other book. So let's say this second book costs, we're in the variable, all this says is we need to come up with something that says we don't know. We don't know what this is for a price, so we're going to use a variable x. So, and all that means, x isn't some magic thing. X just means that we don't know the value. Well, we don't know the value of the first book either, but we can find it out in terms of the value of this second book. So if I know that this second book costs, so let's just pretend for a second, and let's just run this thought experiment. If the second book, if the second book, which we're calling X, the second book, we'll just leave it like this. Second book, if it costs 10, then the first book costs $4 more than 3 times this book. So we have to kind of say, well, we have to say 3 times 10 plus 4. And that would be the second book would, or the first book would then cost 34. Now, if the first book cost $1, the second book would cost 3 times, or sorry, we'd take 3 times that cost, 3 times 1, which is 3 plus 4. So we'd say 3 times 1 plus 4, and that equals 7. If, say, it costs 2, then we'd say 3 times 2 plus 4, that's 6, that's 10. And so what we're doing is we're taking 3 times this first book and we're adding 4. 3 times the first book, adding 4. 3 times the first book and adding 4. Now, if we don't know what the first book cost because it cost X, instead of saying 3 times 10 plus 4, or 3 times 1 plus 4, or 3 times 2 plus 4, we say 3 times X plus 4. So that would be the price of the first book. And so we would write it like this: 3 times X plus 4. Okay, so that's kind of the first thing. They call this, setting up the equation. That's what we just did. We declared our variables and we declared what they mean. And now we have to kind of do what they do, part 2, which is called solve the equation. So if I have 2 books that together cost me $72, well, I know what the first book, I have to add them together. Now, do I know what they cost? No, but I do have these expressions that tell me how much they cost. So if I add the first book price and the second book price together, I say 3x plus 4 plus x. This is my first book plus my second book, and it says it equals $72. Now, if I want to solve that, I can just combine my like terms. Here's my like terms, and I get 4x plus 4 equals 72. And I'm just going to solve this like I know how to solve equations. 4x equals 68. Divide by 4, divide by 4, and I get x equals 17. So now I have this variable. I know what x is. X is 17. So now my second book price is 17. And if I know that my second book price is 17, I can find my first book price by saying 3 times x plus 4. 3 times 17 plus 4, and that equals $55. So I have $17 and $55. I box my answers, and I have the answer to question number 1. So let me erase this, and let's move on to 2. So you'll get the hang of this as you do more and more of these things. So you may not know. There we go. That may have been a little difficult, and word problem setting them up is difficult sometimes. But let's see if we can make sense out of number 2. The more practice you do, the better you will get at these things. Now, what do we know? We have Janet is 3 years old. Let's just read this and see what we need to know. Let's not worry about the numbers yet. Janet is 3 years older than Sister Julie, and Janet's brother is 8 years older than Sister Julie. So in this case, how many people do we not know how old they are? Well, we know Janet is 1. Janet is 3 years older than her sister. So let's make that blue, and we'll make her sister Julie. We'll do that in red. And then we got Janet's brother comes along, and he butts his way into this problem. So we got 3 people. We got Janet's brother, and the whole key, and we got Sister Julie. We don't know Janet's brother's name. I guess everyone else has a name. But we have Janet. Oops. Janet's blue. Janet's brother, and Julie. So let's look and see if we can figure out how old these people are, all relative to each other. Okay, so let's see if we can make sense of this. So Sister Julie is younger than Janet. So Janet is 3 years older. So if I tell you that Julie, here, let's just do a thought experiment. So Julie is 10, then Janet is 3 years older. So Janet is 10 plus 3, or 13. If Julie is 1, then Janet is 1 plus 3 equals 4. If Julie is 5, then Janet is 5 plus 3 equals 8. If Julie now is X, because we don't know, it could be 1, 2, 3, 4, 5, 10, 20. But if we use this powerful X, then it can be anything. And then we can express Janet's age as a function of Julie. So if Julie is 10, 10 plus 3 is 13. Julie's 1, 1 plus 3 is 4. Julie's 5, 5 plus 3 is 8. So if Julie is X years old, then Janet is X plus 3. She's always 3 years older. So let's write that down. So Julie is X. Wait a minute. Julie is X. Julie is X. Right. So Janet is X plus 3. Janet is X plus 3. Right. No, we had that right. Okay. So now Janet's brother. So let's look and see if we can figure out Janet's brother. So Julie, again, if Julie is, now let's just write this up. Julie and Janet's brother. So if Julie's 1, now let's say if Julie's 10, Janet's brother is 8 years younger than Julie. So 10 minus 8. So he'd be 2. If Julie was 20, we'd do 20 minus 8 equals 2. If Julie was 100, 100 minus 8 equals 2. But let's say Julie is X, because we know that Julie is X up here. So Janet's brother is, again, it's whatever Julie is minus 8. So we're going to write in x minus 8. And that's going to be Janet's brother's age. Is this making sense? Hopefully this makes some sense. And there, we've set up the problem. Or at least we've defined our variables. So we've said that if we ever find out what Julie is, we can always just take that number and add 3 to it and get Janet's age. And if we can ever find out what Julie is, we can also subtract 8 from that number and we'll know what Janet's brother's age is. Let's see what else we know in this problem. The one bit we haven't said anything about is the sum of all of their ages is 55. Well, what is the sum of these 3 people's ages? Well, we don't know the numbers exactly, but we do know the variables. So we can write it out. X plus x minus 8 plus x plus 3 equals 55. So let's combine these terms, x plus x, right? We're going to combine our like terms, 3x, and when we combine a minus 8 and a positive 3, we get minus 5 equals 55. Add 5 to both. 3x equals 60. So x equals 20 after we divide by 3. But we're not done with the problem because we've just found out what x is. So x is Julie's age, so that's 20. And now we know what Julie, because we know what Julie's 20, we know that Janet is 3 years older, or x plus 3 as the problem says. So Janet is 23. And Janet's brother is 8 years younger than Julie. So we know what x is 20. 20 minus 8 is 12. So Julie's 20, Janet's 23, and Janet's brother is 12. Okay. Let's keep going. Let's do two more. 2 more for this video. So there's a lot of these problems that are these consecutive number problems. And the way that it's interesting, these consecutive number problems, they actually can be pretty easy. But let's think about it. If I tell you a number, let me tell you a number, and I want you to tell me what the next 2 consecutive numbers are. Consecutive means in a row. So if I tell you the number is 2, you're going to tell me 3 and 4. If I say 5, you say 6 and 7. These are 3 consecutive numbers. If I said the number is 100, tell me what the next 2 numbers are, consecutive numbers. Okay, got the hang of it? Okay, so the interesting thing about consecutive numbers is that you can represent them. Consecutive numbers can be easily represented with algebra, with expressions. So if I have a number, let's remember 3, 4, and 5. How did I get from 3 to 4? I added 1. And how did I get from 3 to 5? I added 2. So if I can say any number here, let's say I have 5. I can add 1 and I get 6. I can add 2 and I can get 7. And this pattern works for any consecutive numbers. If I want 100, I can add 1 and get 101, or I can add 2 and get 102. So let's say my first consecutive number is x. How can I get to the next number after x? I heard someone say x plus 1. You would be right. And if I want to add 2 to get to the next one, I would say x plus 2. So consecutive numbers can always be written as x equals the first number, x plus 1 equals the second number, and x plus 2 equals the third number. And so if 3 consecutive numbers equal 1623, I can say, well, what are these 3 numbers added together? x plus 1, and x plus 2 equals 1623. So if I combine these terms, I get 3x plus 3 equals 1623. Or, subtracting 3, 3x equals 1620. Or x equals, divide this by 3, and you get 540. So I get 540, 541, and 542. And those would be my 3 consecutive numbers. So while we're at it, I want you to tell me how we can do this exact same problem, but do it with that 3 consecutive numbers add up to 15. Here, let's just write this. This is like problem 3b. 3 consecutive numbers add to 15. And for those of you who said, well, it's the same problem, you'd say I'd set it up the same way, x plus 1, and x plus 2. Those represent 3 consecutive numbers, but instead I'd say x plus 1 plus x plus 2 equals 15 instead of 1623. And I'd say 3x plus 3 equals 15. Subtract 3, and I'd get 3x equals 12. And I'd get x equals 4. And so my numbers would be 4, 5, and 6. And how cool is that? 3 consecutive numbers, 4 plus 5 plus 6, and they sum to 15. And we used algebra to figure that out. All right, let's do one final problem. And so that if you're doing any part of these right, you should congratulate yourself, because there's the setup part, there's the solve part, there's just the what is this problem asking part. Let's not do that one. I don't like that one. Whoops. What did we do? Let's go here. Okay. Let's see. Subtract. Let's do this one. The sum of 2 consecutive even integers divided by 4 is 189.5. Now let's think about it. If I tell you 2 consecutive even numbers, I like this problem. I like this one. 2 consecutive even whoops, what am I doing? Even numbers. 2 consecutive even numbers. Even. Okay, so if I start with 4, to get to the next number, you'd say it's 6. That's plus 2. If I say 10, the next consecutive even number is what? 12 plus 2. So the way that you get to the next consecutive even number is you add 2. So if I have a number x and I want to go to the next even number, I have to add 2. So when you're dealing with even numbers or odd numbers, you have to say x is the first number, and then x plus 2 is the second number. So that's different than just consecutive numbers, which is like 4, 5, 6, or 1, 2, 3. Consecutive even numbers is 10, 12, 14. So the second number is 2 more than the first number. So let's see what this says. The sum of 2 consecutive even numbers divided by 4 is 189.4. So let's see, the sum of the numbers is x plus 2, but I have to divide the whole thing by 4, and that equals 189.5. Well, the way that we fix this problem and we start to make sense of it is we now combine like terms. 2x plus 2 over 4 equals 189.5. Now we got to, if we multiply both sides by 4, then this can cancel here. and then we get 2x plus 2 equals, well, 180, I hope I do this right. 189.5 times 4 is 0, carrier 2, 36, 38, carrier 3, 4 times that is 35, carrier 3, 758, and then we got 1 decimal. Well, let's see. 4 times 190 would be 760. Yeah, so I think this is right. 756. So that equals, or 758. I'm going to bring this all up here and go 2x plus 2 equals 758. Subtract 2, and get 756, 2x. Divide by 2, and I get x equals 3, 1, 7, 8. 378, let's see, 378 and 378. I'm checking my work here, 6, 1, 5, 1, 7, 56. Yeah, so x is 378, and then x plus 2 is the next even number is 380. So those are my two numbers. So we've done 4 problems here. Again, the whole key is figuring out, well, what numbers do we need to know, or what are the unknown things, and then like first number and second number, and then creating expressions that represent those numbers, and then using the rest of the information in the question to answer the problem. We'll do more of these as the year goes by, but we can't. I can't do 20 of them all at once because that'll just bore you to death. So we're going to call this good, and we're going to leave you with that. Hopefully this was enlightening and helpful. Feel free to ask me any questions. Send me emails, dlipscomb, DLIPSCOMB @stsimon.org. stsimon.org, and I maybe put together some more videos in the future. Thank you and good night.